This question says, a study found that 35% of residents in a particular city prefer using public transportation over driving personal vehicles. To verify this, a researcher takes a random sample of 200 residents. What is the probability that the proportion of residents in the sample who prefer public transportation is greater than 40%? So before we answer this question, let's first just write down what are all the numbers that we're given. The first number is that the population proportion of the residents who prefer public transportation is 35%. So we can denote that as P, the population proportion, is equal to, as a decimal, let's write that as 0.35. Then we're also told we're going to take a random sample of 200 residents. So that value is going to be N, the sample size we're going to use is 200. And lastly, we want to know what's the probability that the sample proportion is greater than 40%. So the sample proportion, we denote that as P hat. The sample proportion is equal to 0.40 as a decimal. Now to actually find this probability, what we need to do is calculate a z-score for this particular sample proportion. But before we calculate that z-score, we need to first check two conditions that tell us if it's valid to actually calculate a z-score. And those conditions are, the first condition is n times p greater than or equal to 10? And the second condition is n times 1 minus p also greater than or equal to 10? And these two conditions, these are often referred to as the normality conditions. And the idea here is that we want to make sure both of these conditions are met so that the sampling distribution of the sample proportion is roughly normally distributed. So as long as these numbers are large enough, we can make the assumption that the sampling distribution for the sample proportion is normally distributed. So then it means it's valid to calculate a z-score. So let's check this first condition. We have n times p, so n is 200, and p, the population proportion, is 0.35. So 200 times 0.35, that turns out to be 70. And 70 is way bigger than 10, so that first condition is met. For the second condition, let's check that too. We have n, again, that's 200, times 1 minus p. So 1 minus 0.35, that's equal to 0.65. And 200 times 0.65, that's equal to 130. And that's also way bigger than 10. So that condition is also met. So because both conditions are met, it means we can proceed to calculate a z-score. So when we're talking about a sample proportion, the formula we can use to calculate a z-score is equal to the sample proportion minus the population proportion divided by the standard deviation of the sample proportion. Now, the standard deviation of the sample proportion, here's the formula we use to calculate that. We take the square root of p times 1 minus p over n. So let's go ahead and write this right here in the denominator instead. Okay, so now let's go ahead and just fill in all the values that we know in this formula. So we get the sample proportion, we're saying that's 40%, so 0.40. Minus the population proportion is 0.35, divided by, we have the square root of the population proportion, so 0.35, times 1 minus 0.35, and that's divided by n, our sample size. And our sample size is 200 in this case. Now, if we simplify a little bit, in the numerator we get 0.05, and in the denominator, this whole mess, this turns out to be 0.0337. And if you punch this into a calculator, that comes out to 1.48. So this is our z-score associated with a sample proportion of 0.40. The last step is we need to find the probability associated with this z-score. So let's go ahead and look up this z-score in a z-table. Okay, so what we're going to do is look up 1.48 in our z-table. So to do that, let's first look up 1.4 in the left-hand column. So that's right here. And then we'll look up 0.08 along the top row. So that's right here. And we'll just find where these two values intersect. So if we draw a line like this and a line like this, they intersect at 0.93056. Now in a z-table, the values inside the table tell you the probability of obtaining a value less than a particular z-score. So this value that we just found, this is the probability that z is less than 1.48. So that probability, again, is 0.93056. But in our problem, we want to know the probability that the proportion is greater than 40%. So what we need to do is 1 minus this number. So in other words, the probability that z is greater than 1.48 is going to be equal to 1 minus 0.93056. And that turns out to be 0.06944. Or as a percentage, we could write that as 6.944%. So that is the probability that the proportion of residents in the sample who prefer public transportation is greater than 40%. So that's our final answer for this one.